All right, so now for example number 7, we're going to do some trigonometric identities. So we've got dx over cosine squared of 2x. Now I want to remind you guys that that's the same as dx over cosine of 2x squared. That's what that means. Okay? Well, you don't recognize that, or maybe you do. What is 1 over cosine?
Sine, tangent, no.
What is 1 over cosine?
Secant.
Secant. So 1 over cosine squared would be secant squared of 2x dx. Which is helpful because secant squared is the derivative of what trigonometric function?
Tan.
Tan. So before I do this though, I know that 2x is a pain. So what am I going to do? Well, I'm going to let u equal 2x. So when I say du dx, it's just 2. Or I could write it as du is equal to 2 dx, right? Now why would I do it that way? Well, I'm going to substitute just the dx. So when I substitute just the dx, that means that I need to get dx by itself. So when I divide both sides by 2, in other words, dx is equal to du over 2 or 1/2 times du. So when I go to do my u substitution on the next line, I'm going to say that I am taking the derivative of secant squared of u du and toss the 1/2 to the front. You guys with me so far?
Mm-hmm.
Does that make sense?
Mm-hmm.
So then what is the derivative or antiderivative of secant squared? Tangent. So I have 1/2 antiderivative tangent of u. Oh, it's not squared, it's just tangent of u. Right?
Mm-hmm.
And then plus c because it's a family of functions. We don't have a particular solution because I don't know a point on the curve or anything like that. Right? So then what's u?
2x.
2x. So we say tangent of 2x plus c. So probably, and this is probably some of the hardest stuff that's going to be on the test, is the trig identities. But what we do in calculus a lot is that we'll have something simple that we know how to do, and then we take something that's not simple and make it look like the simple thing. We know that secant squared is the derivative of tangent, so we took that the original function and manipulated it to make it fit something that we could work with.